And without further ado, we're ready now for the first double act of the day. Let me introduce you to Mr. Kurt Baumgartner and Georgy Kucherin.
All right. Thank you, guys. First off, thanks for attending our talk, and thank you to Hacktivity for having us. My name is Kurt Baumgartner. I'm a principal security researcher with Kaspersky's Global Research and Analysis team. I've been a part of the team since 2010, working and living out of Boulder, Colorado. And this is my friend and colleague, Georgy Kucherin.
Yeah, I'm also part of the Global Research and Analysis team, but I joined not so long ago, about 2 years ago, when I became 18. And at Great, I'm working at analyzing complex threats. I've done research on the SolarWinds attack, on the Finfisher, a commercial spyware, and I do a lot of reverse engineering of target threats, and I like malware analysis a lot.
All right, yeah, thanks, Georgy. All right, so today we're here to talk about a particularly interesting threat group that we've called DiceyF. The story here really has to do with the targeting of online casino development studios and operations studios, which makes this a pretty interesting subject. So first off, the who. What is the who? The who and what? So who maintains continuous unauthorized access to online casinos, development environments, and operations? It's a group that's known actually for quite some time. They've been operational. Some vendors claim that they've been operational for almost a decade. But while we were performing this particular incident research, Trend Micro came forward with a talk at BotConf, and they called this particular group Earth Berberoka, or Gambling Puppet, as they're also known. And there's a previous operation from this group called Operation DRB Control. Other vendors call them unknown. They don't have a name for this cluster because it's changing and it's such an unusual cluster of activity and resources. But we're going to stick with the name DiceyF for reasons that we'll get to in a second. So when you're talking about casinos and targeting casinos, I have these grand visions of Ocean's 11 style attacks and all this. And really, is that what we have? Do we have Clooney, Pitt, duos going after casinos? And the answer is no. But it's still really interesting stuff. So the Trend guys at BotConf, they also said that there's no evidence of a financial motivation, even though these guys have been doing this for years now. They've been supporting their own custom backdoors, malware families. They've been going after casinos for quite some time. In the incidents that Trend looked into, they found that there was exfiltration. They did observe some, but it was source code and customer databases, which might tell you about an interest in money moving, customers. In particular, the incident we're looking at has to do with organizations in Hong Kong and Southeast Asia, very similar to what Trend saw. So first off, what sparked our interest in these guys? It was an unusual delivery of PlugX, of all things. But it was signed with what looked like a stolen certificate. And the stolen certificate had to do with a secure messaging client, a pretty obscure one, Mango. And this is interesting because past operations, Gambling Puppet, according to Trend, has been using other clients to deliver PlugX and ORAT to macOS. And the other interesting thing is that this PlugX delivery was through there was an employee monitoring system, and then there was also a security center distribution. So the installer itself was signed with this stolen certificate, and then it was sent out within an organization from a security center distribution service. So they had access to everything. And then finally, there's a .NET file that maybe a week after we initially saw PlugX within this environment that had a bizarre PDB. And it was signed with the same potentially stolen digital certificate. And you'll see down here, their PDBs are pretty explanatory. as far as development goes and the functionality and sort of style of these developers. So that certainly sparked our interest. Another thing that sparked our interest is that this GamePlayerFramework downloader was calling back to the same command and control server as the signed PlugX payload that was delivered to this customer maybe a week prior. They were using mango.exe, this secure messaging client file name. They were using the digital certificate, and they were using the file name. So they were really trying to spoof this secure messaging client app. And then finally, it's interesting that there are all these puppet loader strings within the PDB files themselves. So with that, those .NET objects that we're talking about, the GamePlayerFramework itself, will dig into, or Georgy will dig into technical details of that framework.
Okay, thank you, Kurt. So, when Kurt discovered those GamePlayerFramework samples, he gave them to me to reverse engineer. And so I had to dive into this malware framework and analyze it. And while doing it, I found many interesting things that I want to show you right now. So first of all, when you have this large collection of files, a large collection of malware samples that belong to the framework, the first thing that you do is called basic static analysis. You just look at the files in general to find some interesting artifacts. And in our case, such an artifact, as Kurt had already mentioned, it was a PDB path. PDB paths, they are important for malware analysis because these paths contain a path to the folder where the source code of the malware is located. And we can use those PDB paths for malware attribution, for example. So in our case, the PDB paths contained a string called GamePlayerFramework, and there were also in this GamePlayerFramework folder, there were two subfolders. They're called Tifa and Una. And we believe that Tifa and Una are kind of branches. So there is a GamePlayerFramework, and there are two branches out of it, the Tifa one and the Una one. And when I saw this PDB path, I immediately wanted to know what Tifa and Una is. As I have already said, PDB paths can be helpful in the attribution. Like, for example, you can find the name and the last name of the malware developer if you're lucky enough. So I needed to find what Tifa and Una was. So I first supposed that it was Tifa and Una were some words in the malware developer's mother tongue. But when I looked at something that could connect Tifa and Una together, I found the game Final Fantasy. And Tifa and Una are female characters from this game. So this means the presence of these folders could mean that the malware developer is a fan of Final Fantasy. And he may have left those folders as an Easter egg for us malware analysts. And as for the branches themselves, the Tifa branch, we spotted it first in November 2021. But then, in 2022, the Tifa branch completely disappeared and was replaced with the Una branch. So we may suppose that the Tifa branch is just an older version of GamePlayerFramework, and Una branch is a new version of the framework. So then I had to find the among these many files of the framework, I had to find how the infection started. I looked through the files, I looked through our antivirus telemetry, and I found out something that looked like an installer of the framework. And while browsing through telemetry, I found out that this installer was distributed through the victim organization network. So what happened is that the attackers, they compromised the victim network. And after doing that, they started deploying the framework over the machine. So this framework is used as a post-exploitation framework. And what was interesting about the installer is that it didn't look like a common targeted malware installer. Usually, if you are a sophisticated threat actor and you want to deploy malware to victim machines, you try to do it as silently, as invisibly, as subtly as possible, so that no one notices anything. But in our case, everything was vice versa. And when I opened the installer in the decompiler, I noticed that it has a graphical interface, which is very uncommon. So they display to the user a fake window, and while they're displaying it, they are installing malware. And if you are doing graphical installer malware, graphical interface malware installers, there is a problem. You need to convince the user that your window is legitimate, so that the user doesn't suspect everything and go to the IT department and cry, "Oh, I'm infected with malware." In order to do that, in order to prevent that, the attackers used social engineering. Let's look at the window that they display. In it, there are some interesting strings. Let's look at here. Mango account data synchronizer devoted to the victim organization name. So what they did is that they know what victims they are compromising. They included the victim organization name in the strings in the window. And another thing they did, let's look at the other string. Employee accounts need to be bound with IP addresses. Please go to the 10th floor to find the IT department to bind. So they did not only discover the victim organization name, they also conducted research, conducted reconnaissance on the victim's office, and they found out the floor where the IT department is located. And when a usual user, like a person who is not very familiar with cybersecurity, when an ordinary user sees this window, they may simply think that, oh, it's something from the IT department. They say where the IT department floor is, they have my organization name, so yes, that's truly legitimate. That's not malware. That's what an ordinary user could think. But in my opinion, such reconnaissance, they researched the victim organization floor plans, they found out where the IT department is. Such reconnaissance is not common for targeted malware, and I think it's really amazing. So, what this installer does is that it writes the framework files to the System32 folder. This is the first thing it does. And then it, for some reason, creates copies of system DLLs inside System32 folder. And after doing that, it establishes persistence. Now, writing files and establishing persistence are a really common thing for malware installers. But what about creating copies of system DLLs? Why would you need to duplicate DLLs? Let's look at this step in more detail. Like in System32 folder, we have the system DLLs like kernel32 DLL, ADV API 32 DLL, and user32 DLL. What the malware does is it copies these DLLs and other DLLs to the same folder, but it adds an S to the name. Like kernel32 DLL becomes kernel32s.dll, and user32.dll becomes user32s.dll. But why would you need to do that? It turns out that the framework components, it doesn't reference the original DLLs. It references copies of the DLLs, like it imports function from the S functions. There may be two possible explanations about why they do that. The first thing that they wanted to prevent is to prevent analyzing the malware in a sandbox. Let's suppose that you are a security operations center analyst, and you have some suspicious activity going on. You notice the malware, the files that belong to the malware framework, but at this point of time you don't know whether they are malicious or not. In order to find that out, you want to take those files and plug them into the sandbox and see what the sandbox thinks. And when you do that, the sandbox will refuse to load the files, because the sandbox, if you don't have the installer, if you have only the framework files, the sandbox is going to contain only original DLLs. It won't contain SDLLs. And that is why execution on a sandbox would fail, and there would be no information about the samples. And another thing that is possible is that they wanted to evade extended detection and response solutions or other security solutions. Security solutions like to set hooks on DLLs. They need that in order to intercept calls to functions and to track which function is called, and then correlates called functions with some rules in order to detect malicious activity. But EDR solutions, they may not set hooks on the copies, they may only set hooks on the original functions, and thus when the malware will call a function from the copy, it will not get logged in the EDR, and the malware will be able to perform the activity in a silent way. So that's it for the copying, and now as for persistence techniques, they always change them, probably in order to make it harder to detect the samples. In the very beginning, in 2021, we saw them distribute using the services. They created a service and they configured it to load on startup. The service names were called Certificate Manager and Mongo Update. Then they switched to scheduled tasks that had the same names, Certificate Manager and Mongo Update. And after that, they switched to another trick, which involved copying a DLL called res custom s.dll, and then putting the path to this DLL in a key belonging to the RESTman service. RESTman service is a standard service that comes with Windows. And if you specify the path to this res custom s.dll, the RESTman service will load it on startup. By the way, this trick with the RESTman service and the same DLL res custom as, it has been previously used by the manuscript threat actor, which is a Korean speaking threat actor. But for now, we think that they simply, the DiceyF, they simply borrow this trick from manuscript. And that is why we cannot perform attribution based on this trick. But still, the number of persistent techniques is very vast. They always change it in order to avoid being detected. So, when you establish persistence, every time when the victim machine starts up, the framework will be launched. And earlier we saw an anti-sandbox trick that involved copying DLLs. But on startup there are actually more such tricks performed. Like, take this trick for example. It's kind of uncommon trick. What the malware does is that it allocates 10 chunks of memory, and each of these chunks is 50 megabytes in large. So in total, the malware allocates 500 megabytes. And then it starts filling each of these chunks with data. And after writing the data, the malware reads it back from memory and checks that the data is in place. Now, the trick here is that sandboxes and emulators, they may not handle large amounts of memory correctly, like 500 megabytes for example, a sandbox or an emulator that has 1 gigabyte of memory is kind of large. And that is why the sandbox or an emulator may incorrectly handle writing stuff to large amounts of memory. And maybe the writing will fail, or maybe something else will happen. The malware tries to detect such exceptions, and if it detects such an anomaly, then it stops executing. And another trick is it involves setting an error value on Windows through the setLastError function. And then it retrieves it back using the getLastError function. And then it checks that the two values, the set one and the one that has been retrieved from getLastError, it checks that the values are equal, and if they're not, the malware stops running. So these are quite, in my opinion, cool persistent tricks, cool anti-sandbox tricks that are not seen in common malware, especially the one with the 50 megabytes. Maybe they wanted to bypass some kind of EDR sandbox that is not handling large amounts of memory correctly. So the presence of these tricks, it basically proves that malware developers are able to adapt to security solutions installed at the victim machines, and that they are able to create some things that would help bypass them. So if all these anti-sandbox checks are complete, the framework loads its main module. And the main module is a .NET file, and on startup, it loads its configuration from a folder in C program data which is called nvideo. and the file with the config is called dconfig. And once it does that, it connects to the C2 server, command and control server that is specified in the configuration. And what's special about these C2 servers is that they contain the word mango in them, as we will see later, like mango update, something like this. So they also try to masquerade the activity of the framework as the activity of the secure Mango messenger that Kurt told you about before. And once it does that, it starts sending heartbeat packets, and it receives commands from the command and control server. Now the packets, they are all sent through a TCP socket, and it has its own kind of structure for these commands and for these messages. Like it contains stuff like checksums and so on. But what's important about commands is that the commands of the main module, they can, for example, collect a lot of system information, like the computer name, the antivirus installed, amount of memory, the processor, the thing may be required for initial reconnaissance. Now, it also allows to execute shell commands, like maybe to perform some execution, maybe to also perform some fingerprinting of the victim machine. It can also be useful. Then it can be used to download and upload files, maybe just to run some tools, penetration testing tools on the victim machine. And what's important here is that it also allows to manage plugins. The C2 server may request the framework to download a plugin and to install this plugin. And let's look into the plugins in greater detail. So plugins, they, as you saw, the main module, it doesn't have many features, just like basic stuff, command shell, file uploading, just very basic stuff. All the activities of the framework are concentrated in plugins. Plugins are normal exe files that are downloaded from the command and control server. But what's important about plugins is that the malware doesn't drop them on disk. They are all kept filelessly, only in memory. And this complicates the overall process of retrieving plugins from the victim machines. So since they are fileless, let's look at how the main module loads the plugins. So every plugin is run into a separate process. Please look at the screen. I'll show you a demo of how the GamePlayerFramework loads the plugins. So first of all, right here we have our main module process, and as I have already mentioned, every plugin runs in a separate process. And so what the main module does is that it creates an svchost.exe process, and it creates it in suspended mode. Then it injects a plugin downloader through DLL injection, just like it's very standard DLL injection method, just virtual alloc and write process memory. And after it does that, the main module opens a TCP port, and it starts listening for connections on this port. And what the plugin downloader does is that it connects to the main module through that port via a socket. And then the main module, it dispatches the plugin body to the plugin downloader. And once the plugin downloader loads, once it receives the plugin, it starts launching it. And as a result, we have an svchost process with a plugin in it. And then a plugin, it does some stuff, like it on its own connects to the C2 server, requests its own commands from it, and executes them. Now, when we looked into the plugin launching process, let's look at the plugins themselves. The main module, it contains a .NET dictionary with plugin names. And if you look attentively at the screen, we notice that plugins have Chinese names. And this is a very good clue for attribution. By looking at that, we can suggest with at least medium or maybe even high confidence, even high, because we notice that the malware is distributed through PlugX, which has Chinese origins. We can deduce that this malware has Chinese origins based on the Chinese strings that we have here. And let's look at the arsenal of plugins that we have here. What we have here, we have something called acquisition system. That's what Google Translate gave for this Chinese string. Maybe it used to collect some data from the victim machine. Now we have something called hidden process. It can hide processes, hide malicious processes from the user. Then it has a plugin called general purpose. It can also perform port forwarding. Port forwarding becomes useful whenever you want to access an internal resource on the victim machine, and if you want to do it from the attacker machine, you can perform port forwarding, and by doing that, you can conveniently access some maybe intranet, some internal websites on the organization network. You can do it through your own computer if you are an attacker. Now what we have here is screen transfer. It is able to send screenshots, take screenshots periodically, and then send them to the command and control server. Another thing we have is virtual desktop. Just maybe when the user is away, the attacker will be able to control the mouse pointer and the keyboard and do whatever they want. And then clipboard, to capture the clipboard. And there are also plugins that have English names. SSH, just secure shell, also for executing shell commands. Session CMD, maybe also for executing CMD commands. And then 2 plugins for stealing cookies from Chrome and Firefox. Out of these 3 plugins, we observed 3 of them in the wild, which are general purpose, virtual desktop, and clipboard. The other plugins, we haven't observed them in the wild, but we keep looking for them. As for the general purpose plugin, as the name suggests, it provides some miscellaneous commands to the attacker, like create processes, browse and modify registry, create, stop, and start services. It can also turn a machine into a proxy server. Again, it may be useful when the attacker wants to easily access some resources on the local network of the organization. And it also contains some commands that can be useful for performing lateral movement, like listing active network connections and recent RDP connections. By looking at these connections, the attacker may decide which computers to attack next. Now, as for the clipboard recorder plugin, its name is kind of confusing because clipboard recording is not its only functionality. It's also able to log keystrokes. The method used to log keystroke is kind of straightforward and known for a long time. It's by using the getAsync key state function. And as for clipboard, it logs it using the .NET clipboard class. And then it encrypts the data with a simple XOR cipher. It's very common for malware, and then writes it to disk. And it writes the clipboard files and the keylogger files to separate files. It splits them. Now, as for the virtual desktop plugin, unfortunately we have not uncovered yet its .NET binary, but we have uncovered its configuration. Its configuration, it contains 2 things: a remote address, which is an IP address, and a port. We can suppose that during its work, this plugin connects to this server and just maybe it implements somehow an RDP communication using this server. And what's important about this IP address is that let's look at the domain name to which it resolves. It's called update2.imangolm.com. So here, L here is probably just they replaced an iMangoIM instant messenger. They tried to replace it as an L in order to masquerade the URL. And as you can see, again, they tried to masquerade all the activity as legitimate as belonging to this Mango messenger that is probably installed at the victim machines. And so what can you say about this framework in general? First of all, the reconnaissance part is just amazing. How they looked for the floor plans, how they discovered that the IT department is on the 10th floor, and how they tailored the files to the victim organization, and the fact that they used a stolen certificate for the Mango messenger that is probably used at the victim organizations. that is, in my opinion, a very amazing example of reconnaissance. And it also contains quite rarely encountered antivirus techniques, like the technique with DLL copying. It's not commonly met in targeted malware, and then some also sandbox checks that are rarely used. So in terms of reconnaissance and in terms of antivirus detection, this malware performs quite well, I would say. And it also has a vast number of functionalities, like we saw before. A lot of plugins with a lot of functions that allows the malware developers and the attackers to perform whatever they want to do. But however, some things in this malware leave much to be desired. For some reason, they made some operation security mistakes, like the PDB paths. In targeted malware, you have to remove those PDB paths. If you forget to strip them, then it's a mistake, and it allows, as I have already said, reverse engineers to find something about you and about your identity in some cases. And another mistake that we saw is the Chinese plugin names. In my opinion, they should have removed that because it provides a hint that the malware has Chinese origins. Maybe they didn't remove it because they weren't really concerned with attribution being performed. And another thing is that there is no obfuscation in .NET binaries. All the class names like UNE and Tifa, all the method names are there. They are not replaced with some random junk. It's all there. And since they forgot to add obfuscation, it allows to easily detect this malware through, for example, Yara rules. But the most difficult case for victim organizations is to find out that they're infected. And then, once you find it, detection is easy. And overall, the malware, it's a complex framework that performs quite well. It has a lot of functionalities, and it's .NET. It's a new rewrite of the C++ malware. I guess that it's quite sophisticated, and it's quite, for the attackers, it's quite useful. And now, Kurt, please.
All right, thank you, Georgy. Excellent analysis. A few other remarks or notes about the framework that we found throughout this incident. It's interesting that these guys continue to develop this framework throughout this months-long incident. So at the very beginning of the Tifa downloader deployment in those malware modules, they hand-wrote JSON data, JSON formatted data within their executables. So when they were sending up data to command and control servers, they were doing this all by hand. Months later, in 2022, they started adding Newtonsoft library. They started adding more professional support to their .NET modules, which is kind of interesting. They added a few bugs, actually, at the beginning of the development cycle. So that was interesting. They added logging as time went on, so I think they found more mistakes in their code than they expected. They eventually added encryption functionality to cover up what it was they were stealing from machines. And then finally, throughout the campaign, they added these incremental changes, and they actually maintain date-based versioning timestamps in all of their modules. And there were lots of them. So they're doing a pretty interesting semi-professional job of maintaining their code and delivering new code as time goes on. Other oddities about the group and their activity is that they mash all this stuff together. So yeah, they want to be stealthy and they deliver things and they cloak, like what Georgy was talking about, their infrastructure in names that spoof mango.com. So imangolm.com. But they do this they throw all this stuff together. So they'll deliver a Mango executable that's using NVIDIA strings, which is unusual. And then they throw in Final Fantasy strings into that. And then on top of that, they're replacing Microsoft VPN DLLs, which doesn't match any of this, it just doesn't fit. So a lot of what they're doing when they combine it together just makes a bit of a mess and makes them pretty discoverable. Other artifact oddities have to do with previous secure messaging clients that they used. They Trojanized an installer for MimiChat. And here's a statement from the Trend Micro guys. We couldn't find any public source for it, which brings into question whether or not it was developed by the adversary themselves. But we don't have an answer to that. That's pure speculation. But they were delivering PlugX. So with this Trojanized MimiChat installer, and then they were also delivering ORAT on Mac OS. So they were supporting multiple platforms. Even, I think we saw this stuff in 2018 and 2019. I mentioned and Georgy mentioned the NVIDIA oddities. These GUID file names are where they store the clipboard and the stolen keystrokes, and then the heartbeat data is maintained in this .lok file. Again, it's unusual for a secure IM client to store stuff in these paths, so it it's an odd choice. Georgy went over the Final Fantasy characters. The Tifa downloader was, fairly primitive compared to the Unicode. And then finally, the Microsoft VPN support and the other DLLs that they replace in System32 is just another odd choice for a messaging client. And then finally, one other fairly sloppy thing is that within these PDB strings and the rest of the code, when you look back at this 2020 Flash installer that they used as a part of Earth Barbaroka or Operation Gambling Puppet, they used the string puppet loader, puppet core release. And sure enough, 2 years later, with some of their later Unicode, they were calling it Una Puppet Loader Guard. And so they're still incorporating strings and names in their code base. They're borrowing from older code and just rebuilding and reconstructing in .NET, which again kind of gives things away. So that's another odd development choice. All right, and with that, I'd just like to say we have more details in our private report, and we always have trial subscribers and that sort of thing. So we have a 2-part report about these guys and their activity in this particular incident. So if you're looking for more details, we can always get you more details, including IOCs and everything else. With that, thank you for your time, and I think we have time for Q&A.
Thank you. Any questions? Yeah?
Thanks for that. Very interesting. Could you go back to the GUI installer, please? There was a question and observation. So the question would be the reference to the 10th floor IT department. Since the threat actor already had access to the environment, it's likely they probably saw that in some sort of AD user profile, right? Or they just looked on LinkedIn. So they probably weren't looking at floor plans to get that. So I would probably just be less impressed, but it's still good, right? In terms of execution. And what's interesting about that statement, that employee accounts need to be bound with IP address, is that they're not just saying, I don't know, something that you would receive as an employee, read the statement and say, oh, okay, this is linked to the IT department on the 10th floor, which is the strong part of this, right? But they're actually directing employees to go to the 10th floor. So that's really curious to me because it's too strong, yeah? So they get the upside with the 10th floor mention, but then they actually direct employees there. And so it seems strange to me that they do that. And then the observation would just be, from a language point of view, that last line, we've got, Anglo spelling of synchronizer. The others are, US style. So it suggests whoever added that last line was at least educated in English, through a Commonwealth type country. Was there any thoughts on that?
Are you referring to the English English language being used, or that?
No,
You know Chinese?
it's the old S and Z. S, Z, Z.
Oh, that's your edition, right?
Yeah, so what you see here in English text, I added this to the screenshot to translate from Chinese. What I think about the fact that they is the 10th floor, yes, it's some kind of gray area because people may go to the 10th floor and check what the hell is this. But this thing it runs only for a short time, so maybe it will just open, they will read it, they will close it, and they forget about it. Maybe that's how you do it. And as for the Mango account data synchronizer, they probably found out that the organization uses Mango, then they use the certificate, and then they planted this information. So they maybe just, when they got into those organizations, they may have searched for, it still takes time to look at the files that you have, for example, on remote drives, to find the floor plans, some instructions. That's what they did. So anything else?
Yeah, is this working? Yes. Yeah. We're out of time. We don't want to ruin everyone's coffee break, yeah? But you'll have the chance to speak with them for the rest of the day. Thank you very much, Georgy and Kurt, for a dynamic presentation, full of information, and I can see your dedication to the topic, so thanks very much for that. A round of applause.
Yeah. If you guys have questions, we can meet sometime during the conference. Please ask them. Please ask us questions. Don't be shy.
Thank you very much.